Hey, I'm Mitchell. Welcome to another video in the RSP Education series. Today we're breaking down how devices like PLCs, HMIs, sensors, and SCADA systems connect and communicate through network topologies and architectures. Let's keep it simple though. Have you ever wondered how massive industrial systems filled with sensors, PLCs, and SCADA networks, how do they actually talk to each other? Whether it's controlling a water treatment plant or automating a factory floor, the secret lies in how everything is connected. In this episode of RSP Supply's Industrial Automation series, we're pulling back the curtain on network topologies and architectures. These are the invisible highways that keep automation running smoothly. Let's make sense of these systems behind the scenes, clearly, simply, and in a way that actually sticks. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So, what are network topologies? Think of a network topology like the layout of roads between buildings in a factory. Some layouts are better for speed, some for reliability, and some for cost. Some common topologies, one would be bus topology. In a bus topology, all devices share a single communication line. It's simple and low cost, typically used in older systems like Profibus or DeviceNet, but if the main cable fails, everything goes down. Then you have star topology. With the star topology, each device connects to a central hub or switch. It's a lot more common in modern industrial Ethernet setups, since it's easier to manage, and if one connection breaks, the rest keep working. But if the central switch fails, you're out. Ring topology. Ring topologies are commonly used in water treatment facilities where redundancy is crucial for 24/7 uptime. A ring topology connects devices in a loop. Data travels around the ring. If one link breaks, the system reroutes thanks to protocols like Media Redundancy Protocol, MRP. These are great for critical systems that need constant uptime. Mesh topology. So mesh networks are perfect for agriculture, where sensors are spread across large areas with no wired infrastructure. In a mesh topology, every device connects to multiple others. It's often used in wireless networks like LoRa or Zigbee. Very reliable, but more complex and more expensive. So why choosing the right topology matters is it affects uptime, how reliable your system is. It affects speed, how fast data travels. It affects cost, how much cables, switches, and configuration are going to cost at the end of the day. Scalability is affected by the topology selected. So how easily can you add devices later? Redundancy and fault tolerance. In automation, redundancy means backup systems. Fault tolerance means your systems keep running even if something fails. For example, dual PLCs or redundant Ethernet paths in a water treatment plant with the SCADA system help prevent downtime. Industrial Ethernet versus field bus. So industrial Ethernet is the backbone of modern industrial networks. It's fast, it's scalable, and it integrates seamlessly with enterprise IT systems. Protocols like Ethernet IP or Modbus TCP run on standard Ethernet hardware, cabling, switches, routers, and they're hardened for real-time control in factory conditions. In terms of topology, industrial Ethernet often uses a star or a tree structure where devices connect to a central switch or set of switches. This makes troubleshooting easier and allows for flexible expansion. With managed switches, you can also set up ring topologies using protocols like RSTP or DLR to add redundancy, so if one connection fails, the network keeps running. Field bus networks like Profibus or DeviceNet were the standard before Ethernet took over. They are slower, but they're extremely reliable in harsh and hazardous environments. Field bus is typically going to use a bus topology where devices are connected in a series along a single communication line. This simplifies wiring and it can reduce installation cost, but it does make the network a bit more vulnerable if there's a break in the cable. Despite being older tech, field bus still holds value in legacy systems in areas where noise immunity and simplicity are key. So today we've explored the backbone of industrial communication, which is network topologies, from simple bus layouts to more robust mesh networks. Each structure plays a role in how your system performs when it comes to reliability, speed, cost, and scalability. We also touched on the importance of redundancy and fault tolerance because in automation, downtime just isn't an option. And finally, we compared industrial Ethernet with field bus breaking down where each excels and why the choice matters. As always, the key takeaway: the way your device connects is just as important as the devices themselves. For hundreds of thousands of industrial automation products, please go to our website. That's rspsupply.com, the internet's top source for industrial hardware.